Okay, good morning, everyone. First of all, thank you very much for the Heritage Trust Network for inviting me to speak this morning, and to Mark Watson as well. Very pleased to be sharing a little bit of this morning with you about hydropower at New Lanark Mills. So I'll start off really with a bit of an introduction to New Lanark for those of you perhaps not so familiar with it. I'm aware some of you may have visited us, some of you may have not. But before I do, I'll just kick off by a bit of a disclaimer by saying that I am not an engineer, nor particularly sort of engineering kind of minded. So this will be a little bit about the kind of history of hydropower at New Lanark, about how we've kind of got to the point that we're at today. Any kind of more sort of technical questions that you have, I would be more than happy to field them to my colleagues in our facilities and maintenance team, who have more experience in this sort of more technical side of things. So, bit of an introduction to New Lanark, first of all. So the mills were founded in 1785, primarily as a cotton mill, and they really played quite a significant role in the development of the Scottish cotton trade. The mill complex itself was constructed alongside housing for the workers, which established the village not only as a manufactory, but as a place for the mill workers to live as well. The view of the village we have here dates to the 1800s, so sort of early 1800s. And this was the sort of point in time when New Lanark really became most famous, thanks mostly to the work of Robert Owen, who was mill manager from 1800 to 1825. And it was his sort of social and industrial reforms that really put the village on the map. And his ideas of creating an ideal community where working class people had regular access to education and healthcare and good quality living conditions. And it's on really this point that we were inscribed as a World Heritage Site as well in 2001. So we have a lot to thank Robert Owen for. One of the founders of New Lanark, though, back in 1785, was the inventor Richard Arkwright. And it was his spinning machine that allowed the power of water to be harnessed to effectively spin multiple cotton spindles at once under operation by unskilled workers. So initially, Arkwright intended his invention to be powered by horse, but realized this wasn't very efficient. And it was the installation of water wheels that really drove this forward. And if you go down to Cromford Mills in Derbyshire as well, you'll be able to see Arkwright's system in action there as well. Now, over time, the technologies that we employed at New Lanark did develop and change, along with the efficiency of the power systems that we used. So moving a bit forward in time to the 1880s. So in 1881, Birkmeyer and Somerville, who were joint partners in the newly established Lanark Spinning Company, took over the mills. And they diversified production into rope and sailcloth, as well as remaining to manufacture cotton. They expanded what they were producing a little bit more. And eventually, when the Gurrick Ropework Company left New Lanark in 1968, the mills were closed. That was when we finished manufacturing as a kind of whole production operation. And the mills were purchased in 1970 by Metal Extractions Limited, who use the industrial side of the site for a scrap metal business, effectively. This was kind of the view that you would have had in the 1970s, in the 1980s, not the most pleasant, as I'm sure you can imagine. And following the site restoration, we kind of bring ourselves up into the present day. Now, today the site serves a vast number of purposes. We have our visitor attraction, our hotel, all of which are owned and operated by New Lanark Trust. And the houses in the village, which are on the far side of this image, are still lived in today by villagers. So we rent them out to local people, and that helps us maintain the wider village as well. Now, water power has been used at New Lanark since the very beginning, since 1785, to power the mills. In the present day, we use a hydroelectric turbine to power the site, but we're using really the same infrastructure that was put in place back in the 1780s. The technologies have changed, obviously, but the infrastructure itself remains the same. If I could just use can everyone see this sort of laser pointer that I'm using here? Yeah. So the mill lathe that we have running all the way along the site here, this is the remaining infrastructure that we have from 1785. And without this, we wouldn't be able to power the site by hydroelectricity. We also have our water wheel, which isn't operational. Well, it is operational, but it doesn't power anything, so to speak. It's for display. And that is fed by the same mill lathe. Our hydroelectric turbine currently sits in this area. So this is a sort of wheel pit from mill number 3, and it's fed by the sluice gate, which is situated just around here. Once the water flows out of the kind of tail race from the water wheel and the turbine, it's diverted all the way down underneath these buildings here and out back into the River Clyde. And the main reason that New Lanark was built in the location that it was because of its proximity to the River Clyde, but more importantly to the falls of Clyde. And it's the fast flowing falls that provide this kind of suitable head of water for the power of the river to be harnessed for production. So here we have a ground plan that kind of shows in a bit better detail what I've just kind of talked about, the different structure. So this is a reproduction of a ground plan from around the 1850s. And this is the sort of infrastructure that we would be seeing when the factory was operational. You'll see we had 10 water wheels in total, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And these would have powered the whole industrial side of the village. And you'll see here where this water wheel is, this is where our turbine sits today. Now, as the technology advanced, particularly into the later 1800s, the water wheels were eventually replaced by turbines. Now, this is the remaining piece of one of our turbines, our earliest turbine, in fact. This is a Johnville turbine. And should point out, first of all, that this wasn't a hydroelectric turbine. It was powering the mill in a similar way that the water wheels did, in that it was operating a drive shaft that was turned by the power of the water flowing through it. It wasn't connected up to a generator until much, much later. Turbines were much more efficient, though, than water wheels because you're driving the water through at pressure. And that, I say, that would be connected to the drive shaft in the mill that would turn the machinery on the factory floor. Now, these early turbines were by no means as efficient as the modern turbines. This was designed for an output of 440 horsepower. It was intended to power both mills 1 and 2, but it was never able to kind of reach this full capacity. And this piece of turbine we found during the restoration of the site in the sort of late 1970s, 1980s, and we still have it on display here. It's actually just been repainted as well. It's looking very shiny at the minute, which is a joy to all of us, I think, on site. So moving on a little bit to 1898, and it was at this point that one of the turbines at New Lanark was connected to a dynamo that allowed the company to generate their own electricity supply. It was connected to light the mills and the village houses. Although the supply that we had at that point was by no means significant. One villager at the time described the power they got in their home as around 2 candle power. It was sort of a faintly glowing light bulb that they would have in their homes. And this was turned on and off by an engineer at certain points. So there was no individual control for lighting in the homes. It was only in 1955 when the decision was taken to link the village into the mains electricity supply and to use the turbines to drive the mills exclusively. Now, I can move on to the turbine that we do actually have in situ today. And the image you can see in the bottom corner there, that is how our turbine does look today. So this is a Boving turbine from 1931. It was described as the mill engineers at the time as a beautiful, efficient machine. It was placed in the wheel pit of mill number 3, as I mentioned, and it remains there today. It was designed to be capable of 650 horsepower. Originally, the power produced by this turbine was conveyed, as I mentioned before, by a system of rope drives and shafts, but it was only in the 1950s that this was connected to an electrical induction generator, and that electricity was cabled through the mill with motors attached to the individual machines that would allow the factory to run. So over a period of about 40 years, the 10 water wheels that we had that were capable of about 450 horsepower were replaced with 3 turbines capable of about 1,100 horsepower. Now, as I mentioned a little bit before, New Lanark fell into some dereliction in the 1970s and the 1980s, but the work of the New Lanark Conservation Trust restored the housing and the village up to the standard that we have today. As part of this restoration, the mill lathe was drained completely, as you can see here, and the Boving turbine was restored to working order. So, as I said, the turbine that we have today was from the 1930s onwards used to actually power the mills as a kind of fully commercial operation. So it's quite unique in that sense, I think. It now produces about 420 kilowatts of electricity per hour for us. And the turbine that we have provides enough power to supply basically the whole industrial side of the village that you can see here. So our visitor attraction, our hotel, our cafe, our shop, and our spinning facilities as well. So the housing in the village is not supplied by the turbine. As far as I'm aware, that's still linked into the sort of mains electricity. Now, if we produce an excess of power, this can be sold back to the national grid, which provides us with additional income. And similarly, if the turbine's not functional for any reason, or it's being repaired, or there simply isn't enough throughput to power the site, we can also draw from the national grid as well. Normally, there are about 6 cubic meters of water passing through the system per second. But if the river levels do rise, the associated power outputs are monitored to ensure that we're kind of maintaining the safety of the historic site and also the level of the river itself. So if the Clyde is in a particularly dry spell, we can reduce our turbine output to ensure that the riverbed isn't running dry and we're not affecting the conservation of the surrounding area as well. Now, in 2020, a project was undertaken to modernize the turbine. At this point in time, the runner of the turbine from the 1930s, which you can see at the back, the sort of rather rusty looking bit of machinery, it deteriorated since its first installation. It had rusted and corroded, as you can see, but also some of the runners had been quite severely damaged over time, which, as you can imagine, impedes the efficiency of the turbine. So the existing runner was removed from the casing. It was taken off site by Gilbert, Gilkes and Gordon Limited, and they undertook 3D scanning of the runner to produce a digital copy, which was then rendered in solid steel to produce a like-for-like copy of the runner to be installed. And you can see those two next to each other just there. If anyone wants to read the full report on this, by the way, you can do so at the link in on the slide just there. So the runner was reinstalled in the wheel pit of mill number 3. I wasn't actually working at New Lanark at the time that this happened, but I was told it was quite an operation to get a bit of kit that size through a very small space back into the turbine casing. And we've estimated that it was about a 12% increase in power that we got from this restoration. So this brings us up to the turbine that we have in situ today. And as I mentioned, the infrastructure that we use, it's the same lathe and the same sluice gates, the same pathways that we used back in the 1780s. So we do have one other method of drawing power from the water that has helped us increase our capacity and heat our buildings. So because we're a World Heritage Site and obviously a historic site in general, we do try and maintain the historic appearance of the village. So our houses, for example, we don't have any satellite dishes, we don't have any electricity lines showing. So this is all to kind of maintain the appearance of the village as close as we can to how it would have looked in the sort of 1800s. So means like solar panels or wind turbines wouldn't necessarily be the best choice for us because they would obviously be quite visible. So water source heat pumps have been installed along the mill lathe to help us maximize the efficiency of our buildings. These heat pumps work by drawing heat from the local environment, which is used to heat a water supply, which then feeds into the radiators of the adjacent buildings. So there are heat exchange plates that you can see in the image here, situated under the water line of the mill lathe, which extract the heat from the river, making it marginally colder than it already is. These plates are then connected up to a 90 kilowatt heat pump in the adjacent building, which provides the kind of base load heating for the building. If working at an optimum level, this system can deliver around 4 units of energy for every 1 unit of input. And the initial energy generation for this comes from the hydroelectric turbine. So I hope that's kind of provided a bit of a helpful overview of New Lanark's hydro kind of past, but also our present. Um, I appreciate that we are a very, very unique site, and we are very, very lucky to have the existing infrastructure that we do to make a scheme like this a reality. Um, we are I say we are very lucky, and the income that we do get from the turbine output is very important to our operations. It's quite significant and something that we are not we are not shy of shouting about as well, because the whole site, certainly the industrial side, is powered by renewable energy, and it not only is something that we are proud of in the present day, but it also connects us back to our the origins of how the site was powered back in the 1780s as well. So I kind of see it as part of our historical story, as well as part of our just part of our present day operations. If anyone has any questions about anything, I'll do my best to answer them. As I say, I'm not the most kind of engineeringly minded person, but do let me know if you've got any questions about anything. So I will finish up there. Thank you.